Hey guys, why are frogs so happy? Because they eat whatever bugs them. Oh, those are horrible jokes. I realize they're not funny. I don't know why I enjoy these sort of jokes. Anyways, we are solving systems now. So solving a system, and I should have added in the title, of equations, of linear equations is really what we're doing. We're solving systems of linear equations. And what we're going to be doing here is, or what I want you to be able to do, is determine a solution or solutions to linear systems by graphing two lines on the same graph. Okay? So our agenda is, we're going to go over some definitions. We're going to talk about what a one solution looks like, what a no solution looks like, and what infinite solutions look like. I'm not going to, in this video, give you an example of each one. I'm going to be giving you examples of those in class, but I am going to just show you through two examples how you would go about finding out what solutions there are. Okay, here we go. So a system, it's two or more equations that can be graphed. Now, that's actually not the technical definition of a system in math, but it's our definition. It's a definition that works for Math 8. So for us, it's two or more equations that can be graphed. A one solution system has two equations that intersect at one specific point. So I'll be sure I show you something that looks like that. A no solution system are two equations that run parallel and never intersect. And then an infinite solution system is two equations that are exactly the same. Okay? Let me give you some examples of what that might look like. We're going to graph these two equations in just a second, but I'm going to use this space to show you what a one solution system would look like graphically. Okay? So if you had a one solution system, you're going to end up graphing two lines. So these lines would extend infinitely, but these two infinite lines are going to intersect at one specific point. And the point at which these two lines intersect is called the solution right there. And that's the one solution. Okay? And if a system has one solution, you have to tell what that solution is. That's very, very important. Let me show you what a system would look like if we have infinite solutions. Okay? An infinite solution system, trying to erase all this, that's kind of strange. An infinite solution system are two lines that are exactly the same, infinite solutions. So at first the equations may look different, like if I had y equals 2x plus 1, but originally, and then I had a second equation that looked like 4y equals 8x plus 4. If I solve this bottom equation for y by dividing everything by 4, look what happens. I'm left with y equals 2x plus 1. So the two equations are really exactly the same thing. And when you have two equations that are exactly the same thing, what happens is the lines run right on top of each other. Okay? The lines run right on top of each other. So let's say I have a line like this, and then I'll change it to blue for the second equation line, and that line is going to run right over the top of this one, so you actually can't really even see it. And what that means is every point on both of the lines is an intersection of both of the lines. So if the equations are the same, we say infinite solutions. Let me quickly give you an example of what it would look like if there was no solution for a system. So a system that would have absolutely no solution. Okay? Let's talk about that for a minute. If something has no solution, that means they never intersect. And the only way we can say something's never going to intersect two lines is if they run parallel to each other. So these two lines right here are running parallel to each other. No matter how far they go out, they're never going to run into each other. And because of that, we say no solution for these. There's no solution. So really, when you're trying to determine, based on two equations, what the solution is, you just graph them to see it. And I'm going to give you two quick examples of that, where I graph them to determine what the solution might be. And the examples we do, most of these are going to have one solution, okay? Because that's good for practice. So I'm going to quickly graph this top equation. I'm going to do it quickly. I'm going to first start with the y-intercept of plus 3. So I'm going to start there at y is 3. Then I'm going to use the slope to graph more points. So 4, my slope is 4. That can be written as 4 over 1. So I'm going to rise 4, 1, 2, 3, 4, and run 1. Okay, so I have that now to plot. Okay, so I can use my graph line and show this graphically with a blue line here. Okay, perfect. Let me extend that just a little bit. All right, now I'm going to do the same thing for the other. I'm going to graph the other equation now. So I'm going to start at the y-intercept of -2. Okay, -2 right here. And then I'm going to use the slope to graph more points. This is a -1 slope. So I'm going to go down 1 over 1, down 1 over 1. And now I'm going to connect these points with a line. And I'll use the color red, just for fun. I like red. And I'm trying to get that somewhat close. It's way off, so let me fix it. Okay. Make sure I get that just a little straighter. You got to be really careful with these. The biggest hint that I can give you is use a ruler and try and be very, very accurate. Otherwise, if you're off on your lines, they're not going to appear to intersect in the right place. Well, this appears to be the intersection. Now, if some of these lines, they could intersect, in between a section on the grid. If that happens, you can kind of estimate what it would be. For most of the examples, though, they're going to be whole numbers. So this is slightly off, but it's pretty close. It looks like they're intersecting at the x point of -1 and then the y of -1. So this point here is -1, -1, 1. So what I would say for this is I would say there's one solution because they intersect at one point, and that solution is -1, -1. In other words, -1 represents the point at which both lines intersect. So there was a lot to that. But the first thing I did was graph both lines. That's the first step, graph both lines. And the second thing you need to do is see where they intersect. If they intersect at only one point, that means there's one solution, and give that point. If they intersect on all points because they run over the top of each other, that's infinite solutions. If they run parallel and never intersect, then there's no solution. All right, guys, one more example, and then we're done. So I got to graph this, and this is a weird one, this top equation. So I've got two equations here, and I want to know where they intersect, if they intersect. Well, if you have an equation like y equals just -1, there's no x, there's no slope. All that means is that every number, every number here, you go to y is -1, and every number is going to run across this y is -1 point. So anytime you don't have a slope, every time mx is missing, that means that m is 0 and you don't have a slope, so the line is flat. So these are actually super easy to graph because you just look at the number and go, okay, -1, and you draw your line right at y is -1. And it's a flat line because there's no slope. Okay? But now I got to graph this other line. So this other line doesn't look too difficult because I got a nice y-intercept. So I'm going to start here at the +4. So go up 1, 2, 3, 4, put a point. Now I'm going to use the slope to graph more points, but because it's negative, instead of rising up, I got to rise down. So I'm going to go down 5, 1, 2, 3, 4, 5, and over 2, 1, 2. Oh, it looks like I already know where they're going to intersect. Let me do it one more time. Down 5, 1, 2, 3, 4, 5, and over 2. Perfect. I'm going to connect them with a line. Maybe I'll go with yellow this time. And it's pretty obvious right away where they're going to intersect. These two lines intersect right here at the point x is 2 and y is -1. So again, we have a system with one solution, and that solution is 2, -1. Remember, this is kind of a weird thing we haven't looked at too much in the past, but if there's no slope, it's a flat line at whatever y value it gives you. All right, guys. That's pretty much all there is to this. I'm going to give you your number clue. I know I went kind of fast through this concept to keep the video somewhat reasonably short, so we're going to be going over this in class in some other ways as well. But watch this video intently. You'll get a lot from it. All right, number clue. It's more than 40. Good luck, guys.